Hello everyone and welcome. My name is Amin Antasharian and the topic I chose to talk about for my project is called Camless Engines. I will go through a quick introduction, then move to technical feasibility to talk about current situation, benefits and drawbacks of the system, and then talk about economic feasibility for manufacturers and for the customers. Camshafts have always been an essential part of internal combustion engines to open and close intake and exhaust valves. The biggest issue with them is having a fixed profile. In recent years, by using advanced valve trains, we gave some flexibility to timing and duration of valve openings, which was a huge improvement to engines. Camless systems use an actuator to do the job and give full control over motion of valve. So let's get into technical feasibility. Currently, the technology is still in development and testing stage, and there are no mass-produced examples available. Companies such as Eaton Corporation, Siemens, and Freevalve have built working prototypes and are testing the reliability of their systems. When we look at benefits of the camless engine, the biggest benefit is the added efficiency, which is mainly because of the change in motion profile of the valve. As you can see, conventional engines with camshafts will open the valve gradually and then close it in the same way. But unlike them, a camless engine will open the valve, it will stay open and close. This helps the air flow with less restrictions and increases volumetric efficiency. Also, the engine can be optimized better for different engine speeds. Second benefit is that the engine becomes smaller and lighter, as many parts of it such as camshaft, lifters, drive system, and push rods are removed. The added flexibility has some interesting secondary benefits too. A camless engine will be able to work with Otto, Atkinson, or diesel cycle, so it can burn different fuels and even switch to two-stroke mode. So if the system is so good, why isn't it implemented yet? There are some serious challenges on the way of building a camless engine. Electromechanic systems often produce too much vibration and are noisy, because the hardest stops on top and bottom of the actuator have to stop the motion of valve more than 300 times per second in a typical 4-cylinder engine at 5000 RPM. Electro-hydraulic valves don't have that issue, but they can consume too much energy for a pump and pressure solenoids. Also, rough idling and reliability can still be problematic, especially in extreme temperature or altitudes. So let's take a small look at economic feasibility of camless engine. For manufacturers, the extra cost will be more than savings, especially in short term, as they need to make lots of changes to tooling and spend on research and development of new engines. Also, new parts such as actuators, pumps, and controllers will be added to the engine. Fortunately, like any new technology, as time passes, tooling and R&D costs will go down and new parts will become cheaper. So in long term, costs will even out, especially when we look at simplifications as a result of changing to camless setup. Engine tuning and production will become easier, and shorter production lines translate to cost savings. Also, as mentioned earlier, many precision-made engine parts will be removed. The situation is not very different for customer or end user. In short term, the new changes will increase cost of manufacturing and result in increase in price of cars. As time passes, the technology becomes cheaper and so will the cars with the new technology. But one difference between customer and manufacturers is that the customers will spend less on fuel, as cars with camless engines are more efficient. This can justify the increase in price of cars in short term. Unfortunately, I couldn't find a complete cost analysis on camless engines, but from my calculations with the numbers I could find, the added cost to price of cars is very close to fuel saving of customers in about 7 years of normal usage. As conclusion, I can say that the main reason I really like this topic was that most of my resources said implementation of Camless engine is not a matter of if, but a matter of when in coming 10 years. The reason is Camless engines have many benefits with minimal drawbacks, and most of the production problems I talked about earlier, with the exception of reliability in extreme conditions, have been solved. Camless engines are economically feasible, and new EPA standards will only accelerate the development of systems because of the added efficiency. Thank you for listening.